Hello everyone! Welcome to the next video of the series Calculus in Nutshell. In the previous video, we see how something changes over time, and we called that average rate of change. Now we will develop a technique for estimating instantaneous changes. For a quick recap, consider cube of unit side length. If we increase its each side by 1 unit per second, then the average rate of change of volume would be 7 cubic meter per second. So, going back to our problem, the area of growing square. We want to estimate the slope of the tangent line at x equals 1. Let's first compute the slope of two secant line drawn from point 0, 0 and 0.50.25 to the point 1, 1 on curve a of x equals x squared. Now, if you look closely, the red line is steeper than the yellow line. Since the green tangent line is steeper than both of them, the red one has a slope closer to the slope of the tangent line. Now, think what will happen to the slope of red color secant line as we move the point further more closer to point 1, 1. As you can see in the animation, as we move point closer to point 1, 1, the slope of secant lines gets steeper and approach the slope of the tangent line. But what happens if we push the points infinitely close together? If we keep pushing 2 points infinitely close to each other, or in other words, if we keep reducing the value of delta x, then the slope, delta a over delta x, is getting closer to a specific number. In our example, as we push the 2 points infinitely closer together, delta a over delta x gets infinitely closer to 2. This leads to perhaps the most important concept in calculus. As we push one point on a curve infinitely close to another, the slope of the secant line connecting the 2 points approaches the slope of the tangent line. This, in turn, represents the instantaneous rate of change of function at the second point. Now, for better understanding, let's solve an example. Consider the volume of a growing cube as a function of its side length is represented by f of x equals x cubed, and the side length x is growing at a constant rate of 1 meter per second. So, at what rate is the cube growing when its side length is equal to 1 meter? To calculate that, from the graph of f of x equals x cubed, if we reduce the delta x value close to 3 decimal place, the secant line completely overlaps with the tangent line at x equals 1, and the rate of change of volume approaches to the value of 3 cubic meter per second. Though we had developed a technique for estimating an instantaneous rate of change of function, but there's a problem. This method of zooming into the curve or moving 2 points on curve close to each other to estimate the slope of tangent line only gives the approximate results. To find the exact value of the slope of tangent line at any point, we need to develop a new tool known as derivative. But that we will discuss in the next of the video of the series. Until then, goodbye.